Okay, so now let's use our transformations to actually sketch graphs of these absolute value functions. So if we look at number one, or first, let's talk about the steps. So step one is to identify all transformations, and the second step is use the parent function to base your new graph on. So keep in mind, our parent function is a v, and we are really going to focus on the vertex, moving the vertex. You might be thinking, why do I need to know how to graph these by hand when you can just plug them into Desmos? That is very accurate. You can do that. But this will come in handy when we talk about piecewise functions next week and just later in your upper level course math classes, knowing how to identify graphs based on transformations. So looking at number one, our first step is to identify the transformation. So we're going to go left two from the inside, and then we're going to go down one from the outside. Then we are not focused on creating a perfect graph with every single point being correct. All we want to do is sketch a visual what the graph will look like. So if we go and take our vertex that's normally at 0, 0, and we're going to move it left 2, down 1, it's going to be plotted there. And then the next thing we're going to do is just draw a V for absolute value. Okay. Obviously, we're not perfect. We don't know if the x-intercepts and y-intercepts are how we drew it, but this gives us a visual of what it should look like when you graph it. Let's look at number two. So on this one, we have a reflect over x, a vertical stretch by 2, and an up 3. So when we graph this one, we're still going to start at 0, 0 and move from there. So we're going to start by going up 3, and that's where we're going to place our vertex. The other two things we talk about is reflect over x and stretching. So reflecting just flips our graph upside down. When you stretch, if we look back at our transformations, when you vertically stretch, it makes your graph narrow. So that means we just make it skinny. So we're going to make it upside down and skinny. That way, when we make it skinnier, you can see the difference between your regular absolute value and your skinnier absolute value. Let's do one more together. Look at number 2 on the back, okay? I'll let you go back and finish number 1 on your own. But if you look at number 2, notice it has a vertical compress by 1/2. And then it also moves up 1. When we graph this one, we start at 0, 0, we go up 1, draw our vertex. Vertical compress, if we look back at our transformations, a vertical compression made the graph wide. So we are going to take our regular absolute value function and just make it wider so that it is obviously a stretch. So that's what a compress. So that's what a vertical compress looks like. What I'd like you to do, finish these other 4 examples, and we will go over them Monday in class. Have a great weekend, guys. Thank you.